we gotta be for the next 2 weeks. If you look at what we got going here, looking for empty spots. Talking quite a bit about shared, flow resistance. I'm gonna do that as part of the review. Last 2 days of review. I have an assignment for you in the last 2 days, so you actually will get some more practice with parallel resistance. Final practical, probably about 20 questions. Actually, you're gonna have stations and you'll actually look at and do things. Not multiple choice, you actually have identification type thing. Final, of course, about close to 100 questions, multiple choice. And Prop 1, I have that scheduled to be graded very rapidly. You'll get that back. Command 2 I'll be handing out. Chapter 10 assignment is what you just handed in. And with their PowerShell, there's a PowerShell in here somewhere. PowerShell tutorial. Yeah, I don't know if this is eyeballing like it is. Or maybe I put that part of it in the review also. All right, so that's where we're going. Any questions at the moment? All right. I'm not accepting late work too at this point. After the 2 weeks ends, I'm not going to take anything unless you make arrangements with me. I prefer not to take late assignments. At this point, if you have something that you haven't done and you want to turn in, you get half points. So there's an option to get some points if you miss something along the way and you want to turn it in at this point. After the final week, I don't want to take anything. If you do have issues of why you need to turn something late and you have some special case, talk to me individually and we'll see what we can do. So we talked a lot. We're going to talk about sharing today, and then I'm going to pass out some stuff. This one we can probably accomplish today, or we're done by most of it today. That'll be our goal for today. I'm collecting the custom computer and the 20 questions. How hard could one page be, right? Thank you. Any questions?
Yeah. And as of right now, did you already get back all of the
So for the command one, have anything you missed? I'm trying to do clear the decks here.
the BIOS settings we threw, was that a worksheet or something that we?
What's the bias thing?
Yeah, BIOS settings we threw, that was like the 11.
Maybe this one, can we try this one?
Oh wait, the attachment was back.
No, this is people who I've been trying to turn these things back for a while, and if you're not here, I can't turn them back. I don't like to use my else on will argue. If you're not here, I can't turn it back. Today I'm working out these things. Yes, I'm just making this one. All right, chapter 6 is what we're gonna be looking at today. One of the assignments. Let's make sure I got in there. All right, we'll pull it. So basically, we're gonna do all of this. And I've got kind of shared the folder, exercise, shared NTFS permission, we're gonna check into that one. But we've done a lot of it, haven't we? Congratulations on that, what you have done. I think we'll have the time to do it. Operating system lab, I gotta look into it. I'll keep you, by tomorrow, I'll have everything straightened out a little bit more. The last 3 weeks go by so fast, it'll make your head kind of spin, I guess, makes mine always does. Then, it's like, boom, we're done. Don't miss any school for the next 3 weeks. For whatever reason, make sure you arrange your life so that you can concentrate on the next 3 weeks. A lot of points involved, and it can probably cost you a grade or two if you either work on it hard, and that'll probably be up a grade or two. If you have reasons to happen where you can't work on it hard, it could drop you a grade or two. 2 is kind of high, but it could drop you a grade for sure. And if you're where you don't want to be, doubly important. If you are where you want to be, I guess it's just as important to stay there. Confession. Now let's go to chapter 6. These PowerPoints aren't very good. I'll use the book as a supplement. Chapter 6 for your review at home. The catch didn't work. So probably the big purpose for networks the purpose of networks is to share. We need to communicate with each other and share information. By the way, I've been thinking about data, computer data in specific, and I'm trying to think of a simple way for you to remember what computer data is. I'm sure you know what it is, right? So you know it when you see it. I guess to paraphrase famous quote. But if somebody said, "What is computer data?" What would be your answer at this point? What is computer data? Computer, that's kind of emphasis on the computer. Yeah, think about it. What do you, Alex, know about your idea? What is computer data? Information. I'll go along with that, but there's a lot of information. Or how does computer data differ from other types of information?
It's stored as binary.
Stored as, and binary people might not understand, but binary, which are numbers. Now, just but binary numbers, that's not really data in a sense, right? So how does these binary numbers, what has to be special about these binary numbers?
Organization.
Yeah, well, that's another part of it. They have to be organized. I'll go along with that. The binary numbers have to be organized, and what is it? Also, you have to have these binary numbers have to. What's different than just a random set of numbers? They're organized now. They're not random anymore, but they're could be organized random numbers. So, what do the numbers have to? What's unique about those numbers? Now, what do you think is unique about those numbers?
I suppose they'd have to provide instructions. They'd have to.
Well, instructions may be part of it. Anything else? What's unique about those numbers? Besides instructions. What do you know? What about numbers? What are they, what's unique about these computer numbers that are organized? They have instructions.
They mean something.
That's exactly what I want. You're reading my mind, good. It means something. So what is data? Just shorten up and it's like something that you can never forget. Computer data are numbers that mean something. Couldn't make it much simpler than that. Numbers that mean something, right? They're encoded. The information, the meaning is encoded into numbers. So now you know what computer data is. Hopefully you can just hang on to that. That's what it really is. And some of these other things that are mentioned aren't good. The numbers, without organization, we wouldn't ever be able to find anything, right? So even though they have meaning, if we can't find them, that meaning probably would be lost. So we've taken these numbers, given them meaning, and organized them. What can they mean? What does it mean when you say meaning? What can numbers mean? From our this semester, what did we find out the numbers could mean?
Everything.
They can represent words and numbers.
Everything is probably the answer, but specifically, what did we learn this semester they could mean? Within the last couple of weeks.
Sizes. Files.
They could be metadata. They could mean information about the file. I know you want to narrow it down and have a list of things. Everything is too broad. Scope of everything. I probably maybe give you a better argument. Couldn't they really mean everything? But I know what they can mean though. I know they can mean file structure. They can mean metadata. What else can they mean? What do these numbers mean? From our, what we've laughed, what we've done. What does the number mean? Take a look around you. Look at your company. What do you think? Anything you're looking at represents something that they meant? Letters. They mean text. What else can they mean, Kyle? Colors. Colors. They can mean graphics. You did that. And of course, you can't say what the numbers really mean. It's a big fundamental idea. What the numbers mean. That's obvious. But it does, and everything is ultimately, we don't have infinite, but it can mean a lot, can't it? It can mean all kinds of different things. Well, once we got these numbers that mean something, I want to share them with somebody else. So I have to communicate them from one place to another. And the communication occurs via the network. And we're going to look at network sharing and storage. That's what chapter 6 has to tell us. And oh, by the way, people came in. There's an assignment who does not have this point. Verse 1. Do not miss any school. Do not be late for the next 3 weeks. And I'm glad to see you, Danny, because I expect you. I'm just saying, don't be late. Don't miss it for the next 3 weeks. Captain Abbey says it could affect your grade. Check all your the computer.
So you can put this stuff into PowerPoint online.
It's not, I'm gonna see how good it is.
Okay.
I think what it is basically, that what I've been seeing in this book is they just are PowerPoints of the headlines of the book. They don't really have any information on them. That's probably the worst. I'm gonna provide that information, so I don't get me wrong, but I don't think the PowerPoint by itself too much of anything. This one could be different, and it is, if you find it to be useful, I will put it online for you. And I'm just gonna use the guideline to talk about. I've got the book. I've got a lot of ideas to talk about, so. Let's see how good it is. All right, so we're looking at the book, chapter 6. And basically this first slide is equivalent to this here. This is kind of like the format they've been using. So in other words, there's nothing that's not in your book that's on this slide at this moment in time. All right, so I'll take this and expound upon it myself and add some context to it. Well, we've dealt with virtualization in Dave's class. And I've kind of talked about before in terms of, we have the physical, which is the hardware, and we have the logical, which is the software. And when Trent was saying that we could just about do everything with data, right? Could we make data numbers act like hardware? Yeah,
Like VR and stuff like
that'd
that.
be cool, wouldn't it? So now I can make something that I have a really abundance of, right, numbers, act like something I have definitely a limit to, which is the physical. Of course, obviously, we can't turn lead or anything into gold or software into gold, so there's gonna be some physical limits, but we're gonna stretch them with the software. So virtualization, we can actually make software look like hardware. Probably not as good, but might be good enough. Huge. Cloud computing depends upon virtualization, basically. Or at least a big part of it, if nothing else. Huge amount of virtualization going on inside the cloud. Then you have the idea of abstract. Mason, what does abstract mean? Something is abstract,
Different.
kind of different.
Part.
Not real, right? Kind of like a part. I think, did you say a part?
Yes.
A part, yeah, set apart is a really good way of thinking about it. Basically, when I operate my automobile, that's a form, almost there's a lot of abstraction going on in the world. You know, when I turn the key on my car to start, or nowadays I just press the button. I don't even know much is going on. I expect to hear noise and the motor's running, but there's a lot of stuff going on in the background. The abstract part is I don't have to worry about it. I just press the button. When do I have to worry about it? When I press the button, it doesn't start. then the abstraction has to come apart a little bit. But basically, most of the time, I just hit the button and I don't worry about it. With virtualization, all I do is I'm using that computer just like it was a real computer, just like it was a physical computer. And it behaves just like I expect a physical computer to behave, just like your laptop behaves. And the abstraction level is such that I don't need to know what's going on behind the curtain, so to speak. Web applications. What's web is, how big is the web right now? Pretty big. How many websites are there? Many. I actually do really think web-based computing probably is one of the directions that we could probably be taking. Or how, that's not really obvious or totally like profound, is it? I think, but I think the web type of interfaces probably are going to even get better and better. Probably what's the biggest thing holding back the whole idea of cloud computing and web-based computing? Probably comes from Dave's class. I've mentioned it several times. It's all network-based, so what's the only problem with a network? As long as it's available, what other problem could we have? And it's obvious question, it's not a trick question. What is the trouble with networks? They're too
vulnerable.
well. Let's say that is true, but also they're generally speaking, relatively speaking, they're too what else? Think about your network experience at home. What's the thing you hate the worst with a network? If it's available, let's say it is available, what's the next thing you hate the worst?
It's not available.
No. Well, you think about it, it's a pretty obvious answer. Think about your experience. Say I want to stream video. Is there anything I don't like about streaming video?
I mean, if your network's slow.
Oh, the answer, I'm looking for obvious question. So you want it available, I'll give you that for sure. And you want it fast. If the network is too slow, and that's a relative term, but if it's too slow for your purposes, it's really annoying. And that bandwidth. You know, if you want to have a good network, you need to have a lot of bandwidth. And if we had unlimited, or at least a very large amount of bandwidth, which means we could have huge amounts of data being transported from one place to another, the sharing idea, we would probably depend upon it even more. this availability thing, though, might be the Achilles heel of the internet. Because the faster it gets, the more and the better we like it, the more dependent we get on it. And the internet isn't exactly, it's very resilient. It's designed to be resilient in terms of not going down, but possibility it could go down. Now, if we're totally dependent on the internet for our business, or for our life, for our, as you mentioned, everything. Keyword for today, everything, could be a problem. But as we go forward, I think we'll see more and more. I don't see any reason why this should stop. It's a trend, right, Mason? The web is a trend. And I don't see any reason it's gonna be slowing down anytime soon. As long as we got enough bandwidth, enough connectivity, enough ability to share, we'll probably see more and more of it. So what's that P at the end of this over here? What does that stand for? When you see a P at the end, it stands for a protocol. Yep, exactly. It's a type of language, it's a type of standardized way of organization, as was mentioned earlier. Way to get things done. The languages, they usually mention language as soon as you hit protocol. What's true about language then, if you have two ends, and you have to do with language, what's got to be true about your two ends of your communication if you're dealing with languages? They have to be agreeing. It's the same language on each end, right? It kind of makes sense. And so that's why we have to standardize these languages. Hypertext transfer protocol versus, and then when we see over here, there's all, I've seen these test questions on certification tests. We want you to identify the difference between these two. That's where the versus comes in, right? What's the S at the end stand for?
Secure.
Secure. And one word, secure. What makes you secure in a computer, probably in this case? What would make it secure? One word.
Encryption.
Secure from what?
Hackers.
Well, what are we doing? We're transferring data from one place to another. What are the things we don't want to happen to that data?
Get dropped.
And yeah, like
I got
all
two
messed up.
words.
corrupt.
Corrupt, yeah. I want its integrity. Do not want it to change, so its integrity should be guarded. We want that to be safe. Integrity has to be safe. And the confidentiality. If I tell you something, if I tell something in confidence, it's just thing between me and him, right? If Dustin overhears it, no, confidentiality isn't as good, is it? Dustin tells everybody else in the room, I totally lost his confidentiality. Now, confidentiality is kind of where I want to focus for a moment. How do I make my numbers confidential?
Encrypting.
What you said?
Encrypting.
That's it, encryption. So, I like to think simple so you can remember things. When you see the S, start thinking encryption. At least your first thought should be security, encryption. Computer security, encryption. You will see more and more encryption as time goes on. And of course, when we're dealing with the test, for my everyday life, where do I definitely want to have encryption when I'm dealing with stuff on the computer? Same on the internet, where do I have to make sure that I do, a couple of things come to mind. Either where do I have to make sure that the information I'm passing across the internet is confidential? You think of one of the two things I'm thinking of?
As I mentioned, you have to encrypt it.
When would you absolutely say to yourself, why do you have to have encryption? See, when?
Why you have to?
Yeah, why would you insist upon encryption?
Make sure no one can intercept it.
Well, would you, if you're going to look at MSN.com, would you absolutely require encryption?
And really,
Not really, but where would you go where you would demand encryption?
banking is.
Yes, banking is one of the big, probably the biggest one. I'm gonna do online banking. I don't want encryption, right?
Right.
I don't want, I want people to know what my bank account is, I don't know what, and for sure, I don't want to know what my password and username is. You know? And so, when you see that S, think encryption. And then they have all kinds of S's. I'm not gonna test you on, confuses me too. We'll talk a little bit more about it, maybe we'll clear it up, but then I'll probably forget about it again. You see the S at the end, you see the S at the beginning. Is two different ways to encrypt it, basically, to provide data security. Security, right? Local versus hosted storage. When you hook up, or even inside your laptop is SSD, that's gonna be your directly attached storage. Very descriptive, right? If you hook up, put in a USB stick into your computer, that's directly attached storage. If you have an optical disk with information on data on it, that's directly attached right to your computer physically. Then you have network attached storage. And now we're talking more like the cloud, right? Maybe have a Dropbox or storage with Google or storage with,
and stuff.
yep. And that's network attached. And there's advantage to direct attached and there's advantage to network attached. Your direct attached is always available, right? But the network attached might have a lot of advantages also. In other words, it's available from multiple devices. It's depending on how much money you have, it's unlimited, so on and so forth.
So how come you can make it, like, how come you can theoretically have unlimited space? You can just have unlimited?
Because they have, it's relative, there is a limit, but it's so large it seems unlimited. They have all these computers and all these hard drives and these big data centers. They're Google data centers and you'll see what they got going.
Just create all the space.
Yeah, and you essentially what you're doing is renting it. So how many apartments could you rent?
Many as you want, if you can afford it.
If you can afford it, exactly. And there's advantage to renting, there's advantage to owning, right? So that's somewhat of an analogy, I guess, not a great one, but when you have directly attached, you probably basically own it, and when it's a network attached. Of course, so you could still own it on your own personal network. Because you could have your own personal network and still have a network attached. You could form your own, because you have different levels of network. You learned that in base class, right? What's probably the smallest network you could have? You have it descriptive by its name. Well, it turns out it's a Pico network. And that's about small, Pico is a very small quantity. And that's probably why the guy's name. And that's probably one or two just maybe directly connected together. Which comes up with this idea of peer-to-peer versus client-server. Peer-to-peer is just regular computers communicating with each other over a network. It's decentralized. Peer-to-peer, nobody's really in charge, everybody's in charge of themselves. Each computer is performing all the functions necessary to do the network, peer-to-peer. Versus client-server. So what do we have with client-server? We have each individual will be a client, and then they'll have some of these other resources. See if I can remember the 4 resources I talked about. 4 big ones, at least come to my mind. I think the research automatically come to mind 4 of them. What are the 4 resources I'm thinking about all the time when I'm dealing with computers? Almost all the time. And someone give me one of them. What's a computer resource I need to be concerned about?
Capacity,
Of what?
storage.
Hard drive. I'll go with that. So I'm thinking about my hard drives, or storage, if you will. And I'll put that, storage is a good one, but I want to have a specific thing to think about. If I'm on a computer, I can go and look at that hard drive. What else am I thinking about from this semester we've had? Talked quite a bit about that would be considered to be a resource for my computer. Need three more.
Memory.
Memory. And I'm gonna put that down as, and primary memory is what you're talking about, right? I'm gonna put that down as RAM. No, it seems like I get three and I get stuck on the last one. I don't even remember what they are now. So I need two more. You're thinking about a computer. This computer has to perform.
CPU?
We've got the hard drive now, we've got the RAM. Actually, you could even think about it with this, what comes to my mind, you could think about the last assignment you just turned in today. Because you were buying resources, weren't you? You bought the RAM, you bought the hard drive. What other resource did you buy?
CPU?
CPU. And one last thing, is very pertinent to what we're talking about today.
The NIC?
Yep, your network. Those are your four resources that come to my mind right away that you're always thinking about. And they are related. Somebody mentioned capacity. Kyle mentioned capacity, and I've been talking. What have we also been talking about the whole semester? Capacity and speed. And those four directly relate to that, don't they? What do you want? Lots of storage. What do you want? Lots of RAM. Not only do I want lots of RAM, I want my RAM and my hard drive to be very fast. CPU, fast and big caches, fast, big cache, everything, fast. Network, fast, right? And I want lots of bandwidth so I can move lots of data. And then I can get my job done, right? I can take that data, I can take those organized numbers, and I can start manipulating them. And once I start manipulating them through software, I think we're back to that. What can I do? Back to everything again, right? If I'm smart enough. If I'm fast enough and if I'm smart enough, look where we come with computers. Look what you got on your desktop right now. And that was how many years now? When did this all start? Back in the, let's say it started in the late 70s. Let's say 1980 for a nice round number. 36 years, right? What's it gonna be like in another 36? It should be interesting. Could be totally different. You never know. It's hard to predict things, especially the future. Anyway, anything network. All right, so network versus local printing. Well, that was probably, they always say that, at least I've read several times, saying networks were probably first formed, computer networks, to share printers. One of the first things people wanted to share. Printers used to be, I don't know, what would you think? Would you say printers are expensive today?
No, they're really cheap.
But how about the ink?
That's
Yeah. So I gotta add the ink and everything with them, paper and everything, so but they used to even be more expensive.
you can get like $20 under a month for a
Yeah.
cheap one.
Yeah, they'll sell you the printer for almost nothing, because they wanna sell you the ink mostly. Or relatively nothing. But it used to be they were very expensive, and also it's hard to, and even you look at right here, Dunwoody, imagine if they had to have printers in every room, the nightmare that would be. Compared to what this system they had, it would just be a lot more printers, a lot more maintenance, a lot more individual time and attention, a lot more trouble. I heard that somebody mentioned, they said that the computer system here at Dunwoody, this new Ferris saves them $250,000 every year. That seems to be exaggerated, I guess, but I have no proof of it wrong. I can imagine though, it does save quite a bit of money. Pretty good system so far, it seems to me. Anyway, so local printing means you have the printer attached right to your computer, probably like you do at home, right? But even now at home, I'm using my wireless network, I share my printer among all my computers. Pretty convenient, right? I got a Mac, I got a bunch of Microsoft. You know, I can print, I got my phone, I could probably print off of that too. A lot of benefits to sharing. Any questions about that slide? Now, I don't think I'm gonna put that up on the board for the reason, unless they see something else that's more enticing, because where is it? It basically is on this right here. And then the information I talked about again is in the chapter. Probably before next semester, I probably will fill in a bunch, use this as my template and fill in a bunch more slides with some of the information we talked about. Everything else gets better. All right, so they left out some of the ones I was talking about, the Pico network, and they're just gonna go for the big ones. Not so much the big ones, but the more often mentioned ones. Local area network, when you think about that, what size are we thinking with local area network? One room, one building,
Building.
several buildings? It kind of depends, doesn't it? There is no firm boundaries saying that it has to be, if you're more than one room, it has to be one local area network. That'd be nice if it was, but they're not. But it is, if we look at the relative size, what's the smallest one?
No land.
The smallest one's gonna be the PAN, personal area network. Two of you get together and you form an ad hoc network to play a video game between the two of you. That's a personal area network. Smallest, what's the next biggest of the ones listed in there?
No land.
Land, the next biggest, that's a room size, maybe a building size,
Metropolitan.
and they left out a couple other ones here. And then we get to what's the next one after that? So we went PAN, man, or land, PAN, land, WAN, no,
Man. Should be man.
PAN, land,
What man?
and man. What is a metro? When I say metro, citywide, yeah. And you see some of those around, like I think Minneapolis has one actually. Anybody signed up to the Minneapolis network? I've read about once or twice, but I'm not personally.
Sounds like,
Maybe you have to live in Minneapolis. I'm not sure.
like the thing where they're trying to get everyone to have free Wi-Fi. Isn't that like a thing in
There's
France?
no free Wi-Fi.
You gotta pay for it.
Oh, you do? Yeah.
Somebody's gonna pay for it. But it's, you're talking physical equipment and maintenance and somebody will pay. But it may be a reasonable price, maybe a sharing cost or so on and so forth, maybe a good way to go, Metropolitan. And why do I maybe want Metropolitan? Why would I want it? Going back to what I talked about, get that bandwidth. Why do I have Comcast instead of something else? Mason, why do I have Comcast instead of something else?
They probably give you the best speed.
My bandwidth.
Century.
I was DSL, I was getting 2-3 megabits per second. And when you try to stream video, it's some days are good days and some days really suck. Now with 20 megabits or so with Wi-Fi, most days are good. Occasionally things suck though. Cause how much bandwidth do I want? Unlimited bandwidth. I want gigabits per second, right? But I can't afford it. But anyway, so then we get to what's the biggest one of all?
The land.
The WAN. Wide area network, that's worldwide, right? Is the internet a WAN?
Yeah.
Sure is.
Yes, it is. The biggest network in the world, the whole cloud situation we got going on. Now, this part that I've been confused before, and maybe at least I'll mention again, you might still not pick it up, but we can do it one more time. The internet is a connection of computers all over the world, right? But we hear a lot about the World Wide Web, WWW. Is that exactly the same as the internet? Is the WWW internet the same as the whole internet? Are they synonymous?
Yeah.
Yeah.
What, oh,
No, that's absolutely no. They're not the same thing. You Google it, difference between internet and world WWW, maybe you'll come up with it. Maybe after you find my thing and come up with something I don't, but they're not exactly the same. The World Wide Web is not the same as the internet. And it's kind of, we saw a slide that kind of makes a distinction. With the World Wide Web, how are we generally communicating with what type of pages? And implied in the name,
HTML.
HTML, which are web pages. Do you have to have a network, does a network have to have communicate with HTML?
No.
Nope. So we can have a network that has no HTML that is still functional. Can that network be on the World Wide Web if it doesn't use HTML?
Yeah.
If you're gonna participate in the World Wide Web, you are gonna be using web pages, you are going to be using HTTP and HTML. That's the distinction that you can kind of take with you, because they're not the same thing. The World Wide Web is not the same as the worldwide internet. They are very similar in the sense that they are all communicating, but to be on the World Wide Web, you have to get into this deal where you have HTML and have web pages, which are formed that way. Maybe I'm wrong here, but I don't think you can have a web page without a form of HTML, right?
You can have them kind of like purely JavaScript. Which that's just
Yeah, so they're probably somewhere along the line it's going to use the HTML protocol. HTTPS and all HTML and so on and so forth. Anyway, so peer-to-peer, what's our distinction so we can, some type of test question, very simple at this level. There's no servers, just computer to computer forming your network. Here we have a bunch of computers and we're going to have another computer which is going to be a repository of resources that I can share with the clients. This is a less centralized system. Everybody has to take care of themselves pretty much. This usually is a more centralized system. And centralized control, is that good or bad? There's really no good answer to that. It's yes and no. In the big picture, centralized control has a lot of advantages. Yeah, but then it probably has some restrictions also, right? I could maybe just come on top of my head. Centralized is good, right? What if my centralized server goes down? Now we can't do anything. If we were peer-to-peer, there is no centralized server to go down. So even if we have a maybe more resilient to outages possibly. But on the other hand, let's say that we're all peer-to-peer and I have 1,000 computers and I want to make a change in my system. If I'm centralized, I'd probably go to the central server, make one change, and then all 1,000 are changed automatically or changed through the centralized server. If I have peer-to-peer and I want to make a change in 1,000 computers, I might have to go from every computer to the next computer and make the same change 1,000 times. The enterprises of today are using the client-server model. Big business does not use peer-to-peer systems. Where would you use a peer-to-peer probably? We talked about a couple days ago. SOHO, right? So small office, home office, we could get by with peer-to-peer. Because the centralized is probably more complex. We have to have more complex software, which probably means more expensive software. We need more expertise in configuration and types of things like that. All right, moving on. A lot of good stuff to talk about all day, right? There we go, I already talked about that, right? Storage options. Talk about peer-to-peer, ad hoc, that's just basically two of them. You may done Bluetooth sharing where you play games with two computers? Could be done. They have to be fairly close to each other, right? Because Bluetooth has a limit, a range limit. I couldn't find one of my quote on it, I think it's 30 feet. 10 yards, 10, not yards, 10 meters. Basically 30 feet. P2C direct link, how do you connect sectors to the direct link? I think our assignment basically could be done that way. The one I handed out could be done with a direct link. What is a direct link? We are going to take my Ethernet cable, which has what type of connectors on the end? RJ45. I'm going to plug it into my Ethernet port on one, plug it on the Ethernet port on the other. But I do have a concern when I hook up two computers this way. What is my concern going to be? And it's going to be to deal with the cable. That's a good thinking, but that's true. It's got to be long enough. I've not been able to find those wire stretchers that work yet. Be nice. Nope, it's got to be long enough. What else do you have to worry about with this cable? Well, it could be. I'm thinking of things I wasn't thinking about. Basically, yeah, it's got to be the right cat number, right?
Right, both ends.
We have to. The cat number has to be high enough, depending on how if we're 10 megahertz versus 100 megahertz versus the gigahertz, we have to have the right cable for that. Okay, so we got to be long enough. It's got to be the right cat number. What else? Does crossover ring a bell? That's been mentioned. Dave's talked probably.
Yeah.
Because we are transmitting and receiving, right? When you built your cables, you probably built it so that the transmit and receive pins were the same on both ends. But when you hook them up between two computers, they need to be reversed.
Straight through or cross?
Because the transmit pin cannot go to the transmit pin, can it? Transmit pin has to go to the receive pin. Now, I have done this, I wondered about that, I hooked up two of our laptops together with what this is called a straight through cable, probably, not a crossover cable, and it works. So how can it work if I take our two laptops and put a straight through cable between them, which is not supposed to work, but they do work? Well, it turns out that our laptops have a feature where they will look at the cable and automatically switch. Will automatically switch the pin numbers internally of your laptop so that the two laptops so that they will communicate. I think I always get confused. Is it MIDX or MDIX? Somebody will Google that, and I'm always confusing which one it is. But it's MDIX, I think. Put that in there, see if that comes up with anything.
For MDI crossover is a version of MDI that enables
Yeah,
connection.
so it is IX. Okay. And your laptops have that option, or feature, if you will. So you can connect up. Now, if you connect these two up together, it's pretty simple, right? Just connect the two up together and then you talk to each other, right? I wish it was so. To be talking to each other, you have to have the physical connection, and then the ISO, the model, 7-layer model, what was the cable level? Physical level, layer 1, right? We take care of that with the cable. We got the right length, we got the right speed, we've got the right crossover versus not straight through. But we're not done yet. We have other layers in the model. And one of that comes to mind immediately is going to be the third layer,
No.
networking. And we're going to have be in the same subnet. So we're going to have to deal, I won't deal with it right now, but we'll talk about that later. But there's a lot of things to think about, right?
Right.
Alright. Well, they're putting the arbitrary limit at 20, no password required. Okay, so, well, as soon as I see no password required, what does that probably mean?
That's secure.
No security. Oh, man. And do I need security? It
Yes.
depends, right?
Yeah.
Not always.
I would love to.
We don't have security in this room, right? Well, we do have security at the front desk,
Exactly.
but we don't have one in every room.
Yeah.
Hey, some of it depends. Any operating, well, this gives us some more flexibility, so any operating system can join, so we might be able to possibly have Max and IBM's communicating, that might be nice. This is decentralized, right? Where is the administration done? Locally. On your computer, I have to sit down at your keyboard and configure it. And that is a problem, right? If I have 1,000 of them, and they are spread over a whole city or maybe over the whole country,
You gotta go all over the
I have to go
country.
everywhere. Not good for that type of deal. This is the point here. How do you, this is pretty important. How do you know they're all in this, from a really first level big picture, how do I know they're all on the same local area network?
They all have the same IP address.
They won't, you gotta be careful there.
They're on the same range.
It's all the same address range, right? They can't have all, they all have to be unique,
Right.
but another way of saying what you just said was they all have to be in the same subnet. So whenever this is probably a big deal for this whole next couple weeks, and whenever we're trying to share things, we are not gonna be sharing anything if we're not on the same subnet. We gotta have a physical connection, but just as important is the fact that we are in the same, probably even more important, because you never think about it. And we have to be careful too, because given the type of class we're using, or if we're using classless, we may think we're on the same subnet, but we might just be close to being on the same subnet. And if you're close to being on the same subnet, how well will your communication go? You're close, right? In other words, maybe I'm at, what I mean by close. Are those two IP addresses on the same subnet?
Depends what the subnet mask is.
You already, it's not fair, you already taken the test, but you're right. Anybody else, what has he just said? Are those two IP addresses rated on the same subnet? They look like they're really close, actually. But we don't know what the subnet mask is. And this is IPv4. You can't tell that by looking at it. Oh, well, close. A little hard, but I'm telling you, it's IPv4. We have to know what the subnet mask is. What would be a possible way these two could not be in the subnet, same subnet?
Limited range.
Well, what are the subnet addresses? What's probably 0, right? And we go 0, 1, 2. So what's the very smallest number of hosts I can have on one subnet? 2. So my subnet could end up, I have to be a little careful, I have to think too, because it's not intuitive, but basically, I could end at 2.
Right. Slash.
I can have a valid address here. I got, this is my network. This is my,
Broadcast.
this is probably not a very good way to go with it.
Right.
How many hosts do I have? But in this case, what if I could get up to, maybe I want to make something that's going to work. But could I have a workable network? Why is this one not workable? How many host addresses do I have with this deal? 0, 1, 2. I've only got one is, will that make a good network?
No.
That'll hurt, because you only got one computer. But I could have something that goes up to, I could have a network that ended at
4.
subnet that ended at 4, which would be totally viable. Now I have 0, 1, 2,
3.
3. And so now the broadcast is going to be, network still 0, broadcast is going to be, actually the broadcast is going to be 3. I spelled that right, might look better. Very common one too. And you probably, David probably talked about this one. So really, I only have, I have the net 0, I have the broadcast 3. So I have client number 1 and client number 2. And that's it.
Right.
Can't be a very big net, can only 2. When would you possibly only want to have 2? I'm getting too far beyond, this is Dave's area. But it turns out that if you want to have a point-to-point, in other words, if you want to go from one area to another area, and you have one transmitter transmitting, the other one receiving, this might be a good address scheme for you. Anyway, I don't want to get too far into that, 'cause I'm not testing on that today. So just to recap, so how do I know if I'm on the same subnet? I have to have not only the IP addresses, but what else? As you mentioned, we have to have the
Same subnet mask.
subnet mask. And we have to interpret the subnet mask so that we know we're on the same subnet. Because if we're not on the same subnet, what's gonna happen in terms of communication? Kyle, if we're not on the same subnet,
We don't have any.
we will not communicate. Is there a chance we might?
Probably not.
Okay. That's why I figured out, there's no chance. You got a good cable, you got a good computer, you got all the things good, you're on different subnets. Guess what, there is a way I can communicate if I'm on different subnets. But it involves something else.
Out through the internet and back in maybe?
Well, we're gonna have to get off our subnet and get onto another subnet. And basically the device I'm gonna need is gonna be called a router. The only way you go between one subnet and another subnet is via, or at least from the level I'm talking about, historically via a router. So our router is important?
Very important.
Yeah, really important, right?
Yep.
Routers and switches. The computer guys are talking more about that. All right, so this one here, I kind of put a little time on it, but it's really incredibly important. Whenever you're trying to communicate, this is probably one of my first questions I ask after physical. Physical first, and then it's got to be, am I on the same subnet or not? Some other ones come up too. There's a lot of ways to stop communications. All right, and that's the third thing that comes up here. So we got our physical, we were on the same subnet. What might prevent us from still communicating? Well, we still may not have permissions to communicate. We're talking security here, right? I don't want just anybody communicating. People have to be authorized to communicate. And before I let them communicate, I usually need to authenticate that they are the people they say they are. So usually with security, I'll have that password, and so I have to start thinking about that too when I'm dealing with sharing. I have to think about the physical. I have to think about the network. I have to think about the permissions and the authentication and authorization and some of the things coming up. Fairly involved. User account, right? Password and username and password. And the resources I need authorizations. Maybe I even let you into my computer. Say I invite you to a party. I open the door and I recognize you. I let you into the party. Once you're in the house, does that mean you go anywhere in the house that you want?
Nope.
Probably not. Physically, you probably can, but you probably are not authorized to go into my personal bedroom or look into my personal filing cabinets or whatever, personal dressers. So getting in is the authentication, but being authorized to use the resource in the computer is another step. And what do I get as the owner? Full control. I can do just about anything I want. Modify is a little less control. Maybe I'm not allowed to delete the file. I can just maybe modify it but not delete it. And read is the probably most basic permission. That's, in other words, I'll let you look but not touch, so to speak. Like I said, printing, sharing was probably one of the first reasons for networks, according to books. In other words, we have a big office, printers were very expensive. We needed a little bit of By the way, what's about the temperature in here right now? Is it cold, hot?
No, it's pretty good.
Not bad.
I'm pretty warm. Cold a lot of times, but
You got your jacket on, it is on, so it can't be, looks like I'm doing all right.
you say you changed the temperature? You can do that?
Yeah, I can do that,
Oh, wow.
but it's tricky because different parts of this room have different temperatures and,
Yeah.
trying to find the optimal temperature, which has been difficult.
It's not bad right now.
All right. Home groups, a little less complicated. We've got home groups, work groups, and active directory groups. And home groups are the simplest. If you just are looking to share some resources and you're not worried about security, you're not worried about centralized control of the system, home groups are a good way to go. Probably homes, right? If you're at home and you have your family wants to share information, a home group might be a good way to go. But when you have to have Windows 7 or newer to use it, so you can't be doing XP. You have to have a password. Turns out though the password is going to be the same password for everybody. Is that a good idea? No, that would be. Well, my bank is the same password all the time. That might be a problem. But at home, if I took my wife, she uses my password. So I trust her. You don't have to be in the local area network. That's kind of neat. It's easier. That's a big thing about work groups. Of course, when things get easier, you probably have to worry about other things. Other capabilities that might not have the security that you might want. But you start out with work groups, right? Or, excuse me, home groups. And then we get into work groups. Okay, let's look at the cloud for a moment. Well, let's go on here. Again, I don't see anything that's on this PowerPoint that's not almost directly page to page in the book. So if you think you want it, let me know. We talked about virtualization. These are probably the three things that any cloud certification test is going to have on it. Every one of them. Anything that has to do with the cloud up to this point starts here. So it's worth memorizing these three things. You ever deal with clouds, you'll be hearing these three terms. Every one of them. It's just everywhere in terms of that idea. So we've got the SaaS, PaaS, and IaaS. Software as a service. And probably what's the most first thing that might come to someone's mind when they think you're talking about getting your software from the cloud? That's probably the most one that comes down most often in the cloud. Or do you talk what service are you going to be probably buying? Maybe from Microsoft.
Security.
I'm thinking Office 365. What's in Office 365?
Word.
PowerPoint,
Excel.
everything that our productivity software that we probably almost indispensable. We need word processing, we need presentation, we need the spreadsheet. So you are basically renting the software. What else do you have to worry about in terms of the network? Nothing. You just go to your web page, call up your software, and you use it just like you would if it was installed locally on your machine. Software is a service. But what can you do other than Word 365 if that's what you purchase? Nothing. That's it. That's all you can do. Software. You are renting the software, so to speak. Maybe you have cloud storage that goes along with it, or maybe you can store your files both in the cloud or locally on your machine. But you are renting that particular software. Then we get into the software developing situation. I think we're all networkers here. And basically the idea then is not as important then. What are you buying now when you are paying for your cloud services? You're basically getting development software, software development interfaces, APIs, application programming interfaces. So now you have software and services, you can actually create more software. Then you get internet as a service. Now we're getting to the point where not only are we getting the software itself and the ability to create the software, we are getting the ability, essentially everything, we're controlling every part of the network. What are we doing? We are setting up computers as our servers. We are maybe even determining IP addresses. We really have pretty much complete control over all the hardware. Before, we didn't have any control of the hardware, we just dealt with the software. Now all of a sudden we have to administer, we have to configure the hardware too. Gives us more flexibility, more complicated, probably more expensive too, I imagine. You are renting hardware now and controlling hardware as well as software, because you have to deal with the software as well. You have to load the software, you have to do everything you would normally do, except that you don't own the hardware it's being done on. You're basically renting it. But that's not totally true. There's always a possibility. That's the public, as I was talking about, right? Maybe you want to buy all the hardware yourself. Be your own ISP, Internet Service Provider. What would be the advantage of that? You'd have complete control over everything, right? And probably higher security. Is the internet secure? If you are passing information to your internet service provider, is that totally secure?
Say less secure.
Some of it.
It's fairly secure. Maybe, it depends, doesn't it?
Yeah.
There's been some issues in the news where somebody had servers, ISP had servers, and I think it was reported that they were in the bathroom. That sounds like a strange place to put your servers, doesn't it? Yeah. I don't know if that's true or not, because nowadays you never know. But when you deal with a internet service provider, how good are they? It depends, doesn't it? So you have something called an SLA, the contract basically. And SLA stands for Service Level Agreement. And it's contract saying they'll tell you what types of things they will provide. Because if you have servers, let's say you have servers in your personal dwelling, you're an ISP and you're selling your services, they don't know that your servers are in your bedroom, right? What could go wrong though, huh? Let's say there's a power outage in the neighborhood. And you are depending, your web page is depending on their services.
Right.
Their servers are now down. How long are they going to be down?
Okay.
Until they come back up again. If you have a service level agreement, let's say you lose $1 million between the time it goes down and the time it comes back up again. Do they have to pay for that?
I guess it depends.
Depends on your SLA. In your SLA, it will tell you the amount of time that they will be down in any given period of time. And if it's more than what your contract calls for, you have an action to recoup some of your losses. If not, you don't have a good LSA, and you don't have any option at all. Alright. And that's what I was talking about. Maybe I've dealt with the Dropbox a little bit. I don't pay for it, but I got some free stuff. A few gigabytes for free, right? Apple iCloud, again, much as you can afford, you can have. Box I haven't dealt with. OneDrive actually comes with, you get a little bit free when you get the operating system, right? And you can buy more. And Google Drive, I've never used it. Anybody used Google Drive before? How much free are you getting right now, you know?
I get as much as I want, pretty much. I haven't had any limit yet.
Cool. Well,
It's pretty awesome.
Google is, that's I always joke, but it's Google's vision to dominate the world.
Totally.
I don't know if that's true or not, but I just like to think of it that way.
Totally. You're doing good.
They're doing so far, not bad. I use Google just about every day. It's a little worrisome when you use Google, the search engine Google, what is true, they're recording everything you ever did or have done. And at some point, he's brought back and somebody could examine all the actions of your Google searches throughout history.
They're super secure though, right?
But if you don't do anything wrong, you have nothing to worry about. Unless, no, all the issues. Everything is always a but to everything. So what's true about the Chromebook?
It's 100% cloud-based.
Cloud-based and it's relatively cheap, right? And so that's the idea that distributed computing. We don't, the Chromebook doesn't do much of the computing. It does a lot of computing on it somewhere else. And the storage is somewhere else. And then here comes that Microsoft 365 they mentioned. That's the software as a service technical approach. So as soon as you talk web, right away, if it's not running this protocol, it's not on the web. There might be some example where, but from the first level when we're thinking about it, what makes a web when it's running that protocol? And then when we want security or encryption, we go to secure. And we have the idea of the ports. And that's Dave Bellywick again, of course. But what's the difference of a port? We have an IP address and a port. Why are ports so daggone important? If I want to have 3 web pages open at a time, 3 different web browsers open at a time, how can the computer determine which one is communicating with what? You got web browser 1, 2, and 3. How does it know which one it's talking about?
Different instances.
With what?
Different instances.
Yeah, and they are different in the sense that they're using different ports. That's the key there. That's the thing to remember, they're using different ports. They're all using the same IP. You only have one IP address for your computer. So how can 3 different, if you call them instances, how can they know which instance you're dealing with? You have to assign a physical port to each one. What is a port? Well, there's a lot to it, but basically we're going to say, with the abstract, I'm going to give you a port is a number. Like door number 1, door number 2, door number 3. So in this case, if I have 3 web browsers running, the IP address is the same for all 3 web browsers, but one's running on port 1, the other one's running on port 2, so to speak, the other one's running on port 3. And I'll leave all the numbering systems to Dave and all the other stuff, but ports are incredibly important. And if you look at it, this is one you'd memorize, and sure you, Shah, you have seen this one before, probably memorized it.
43, a little bit.
Yeah, HTTPS, which goes along with this one. If you gotta go back in your memory, should pop up. HTTP is what?
480?
Yeah. Probably the most famous port of all, right?
Right.
HTTP is port 80. Definitely could be a test question somewhere along the way. My favorite is so easy to remember, NTP, Network Time Protocol. Kind of like a password situation. The Network Time Protocol, what do you think the port of the Network Time Protocol is? So easy. The number, right? It would be the easiest sequence of 3 numbers you could think of.
000.
A little harder than that. Forget about binary for a minute. Think you're in kindergarten.
1, 2, 3.
1, 2, 3. Yeah, 1, 2. That is the actual port number for Network Time Protocol. Stuck in my mind. 1, 2, 3. That's it. And they just go on and on. There's probably for any type of test, for a CCNA test, you probably have to memorize 20 of them, maybe 25, maybe 20, 15. Come on, man. But we're talking encryption here. This was SSH, secure sockets. The socket comes with the fact that you combine a port with an IP address, that makes a socket. And basically, this is the newer version of the same thing. Even though they call it this, probably using that. So this is where we start. We talked about, where do we start with communication here? Probably pretty close to here, right? think I started with sharing a printer. Well, as soon as I get done sharing my printer, I probably need to move files from one place to another. And what type of protocol would I use to move files? How about a file transfer protocol? FTP, you probably might use that in terms of web development, because you want to move web files from one place to another. In particular, where would you want to move your web file to and from? Where do you write your web page on? Your local computer, right?
Right.
Where, before people can see your web page, where does that end up?
Server?
Web server. How does it get from your computer to the web server?
FTP?
Gotta be transferred, right? It's a file, it's organized like we started today. And I could use FTP. Now, if it's very important, I don't want anybody to see my web page, I'm probably gonna use FTPS, secure.
What's the difference between secure FTP and
Yeah,
FTPS?
oh man. Why don't you Google that? You know, it blows my mind. They're both encryption, it's a different way of doing it. One uses SSH and the other one doesn't. And it's like, if I was gonna take a test, I'd have an answer. If I was taking the test tomorrow, I would have an answer for you right now. But yeah, it is for security. And the big thing would be if you're using S on the front and S on the back on either end, then you'd have troubles. So whatever you use on one end, you better use on the other. And they also probably one has advantages over the other and disadvantages. One might be newer, one might be older.
Right. This is really used, it's probably outdated.
Probably, yeah. I don't recognize the port number either, so I can't memorize either of these two port numbers, so. Oh, here you go, it says right here,
Yeah, I mean,
S used SSH,
right.
and this one
One is really
is
used.
really used, so concentrate on this one.
That's funny because it says that's port 990 or 21 and port 21 if there's also FTP, so that's kind of weird.
Yeah. There's a lot to this, we're not at that level, so I don't go there. All right, so let's take care of that. All right, now we got the assignment to deal with. So, let's take a look at that and see what we gotta do. Be prepared for some frustrations, and also you have to be patient when we're dealing with networking. I don't know if you figured that out yet already in Dave's class. Does everything always go exactly the way it's supposed to go? No, if anything go wrong, yes,
You gotta troubleshoot.
be prepared for that. I'll try to help you through it. I know I can be successful if we have patience and we think of it in a logical way and make this work very close to. Let's go through this. And I think we only have 12 minutes, but basically, you look through this first before we do anything for tomorrow. We'll do this tomorrow. You look through and try to, if you can figure out things so you can make this go as fast as possible. Also, I may as well hand out these two. And they won't be due anytime soon, but they'll be due at the end of the, we'll have to work them in so that they will be done at the end of the, before the final week. So when you start thinking about the, give you an idea of the magnitude of what we've actually do. Now, what I understand, this was the direction of power zero. And from two.